Having just laid out a route structure, let's use REST verbs to add lights to and remove lights from our implementation. In order to do that, the first up is to define the JSON structure that's going to actually represent the lights and eliminate the hard-coded unit and house codes. From there, it's going to be time to implement get for individual lights and for all lights, and then we'll implement post and delete for add and remove respectively. And at the end, we'll do a little housekeeping to get ready for the next step, which is preparing for a production environment. So if we're going to define REST verbs for adding and removing lights, the first thing that we're going to need to do is define some kind of JSON object or data transfer object, if you will, a concept of a light. Right now, we're just taking in a command as an argument and hard coding the house and unit codes of the light. So we're going to actually need to define a light as such with house and unit code. And to do that, I'm going to borrow the same kind of approach that we had in the hello class, where I'm actually going to define up front a JSON light. And in order to do that, I'm going to paste in here something I had put in already, which is a lights collection with one light in it called office desk. And that's what I'm going to use in order to read in from this in this put method. So what we're going to go do is add a parameter to the put method in order to take in what light the user wants to actually operate. And we're going to load up from this initial message that we created here, all of the JSON, and then I'm going to write in some logic here for finding the actual specified light within this method. And I haven't defined the parameter of the method yet, but I'll do that here shortly once I get this matching light implemented. So I'm going to say that this equals light ID and then go define a parameter for light ID. And what that's going to let us do is specify the light and what we want to do with it when we're invoking put. And then I'm going to come here and get rid of this hard coding, because like I said, this is critical if we're going to actually be adding and removing lights. So matching lights house code and matching lights unit code. And then we should be all set for an implementation once we go and update our route, because remember, we've added a variable to this method, so we need to do the same thing in the route. And I'm going to specify here that I want to take just anything for the argument for the light ID, because I don't have any specific restrictions on that. So I'm going to run this, and then what I'll do is I'll show you what this looks like and show you that it's still working. So right now my desk lamp is on, so I'm going to invoke the lights office desk off, and I will drag the screenshot of my lamp over here and show you what happens. So I'm going to hit execute on this and we'll expect it to turn off, and voila. There's another somewhat important bit of housekeeping to be done before defining the add and remove via JSON, which is to allow retrieval. So I'm going to define a get method that takes no parameters. So that's going to map to just lights. And what I'm going to do is just return all of the lights, and that's pretty simple at the moment. I'll just return lights.message here, and that will give us what we need. And then I'm going to add that route in as appropriate and route it to the lights class to handle. And then I'll show you how that works. I'll come over and restart the web server, and then I'll fire up Fiddler and kind of show you what this looks like. So what we're going to expect here is to see the currently hard-coded list of lights when I execute a get method. So I am going to get rid of the designation here for the lights. Oops. Get rid of that again. And then I'm going to change the verb to get and execute this. And what we'll expect to see here is, in fact, that list of lights. So there it is. Now I'm going to define one other option on the get method, which is an optional parameter here to specify a light ID, because I think it would be nice for users to be able to get all of the lights or get a specific light by ID. So I'm going to take advantage of this optional parameter to allow two different behaviors on the method. If no parameter is specified, I'm going to return all of the lights. Otherwise, I'm going to return the matching light. And since I've already got logic for matching light here, I'm going to define a method in this class in order to keep the code as clean as possible, so to eliminate clutter. So I'm going to define matching light equals self.getMatchingLight with the matching light ID. And I'm going to define this method with the code that I previously had inside of put. And then I'm going to reuse this code in the actual get method as well. So from get, once I'm finished here, I'm going to return self.getMatchingLight, and then I'm going to add a route as needed for the new parameter that we're allowing to this method in some cases. And this is kind of a nice way to let your get method or any method you want handle multiple different kinds of URL routes. So I'm going to allow a wildcard here again, and I'm going to map that to the lights class. And then, oh, I've got a syntax error down here I want to make sure I get rid of. So I will put the colon here after else. Now I've restarted the web server on my other monitor. And so there you can see we're still getting the same collection of lights back from the original invocation of get. But now I'm going to specify this office desk, and I'm going to show you what happens if I execute there. We now see just the individual light, which is exactly what we were looking for. Now with get and put behaving the way we want them to, it's time to add the post method so that we can add lights on the fly as we go. So I'm going to define post, and I'm going to implement about what you would expect, which is that we're going to take in data from the web request and load it as JSON. And I'm going to do that via web.data. And then what I'm going to do is go and get the JSON that we're currently storing. And I'm going to load that. And then I'm going to append the light that has been fed in via the web request to the actual JSON that we're storing, and then I'll store it back in our statically defined internal store to this class. So I'm going to load the full JSON's lights collection, and then I'm going to append the new light that we've loaded from the web request in there, and then we're going to store that back. And that's going to be the basic implementation of this post method. This is how we're going to be adding lights to this system. So once we have this stored, the other thing that I'm going to have to do is go up here, and I don't really want the JSON message to start off with some default value in there. We're going to be adding that in. So I'm going to cut that, and then I'm going to use that a little bit later when showing you how this works. Another thing I'm going to do here is go through, and in this class alone, I'm going to rename this because message doesn't make a whole lot of sense. That's sort of a vestige from what we were doing before with the Hello World application. So I'm just going to go through here and use Sublime's find and replace feature to replace this with something called lights JSON that makes a little bit more sense. And then I have one last bit of housekeeping, which is I'm going to have to go up to the top here and change the order of these routes. I've been a little careless so far. We want to go from most specific to least specific so that the post method we're defining here actually finds this and not something else first. So I'm going to restart the web server, and then I'll show you what this looks like in terms of adding things via Fiddler. So I'm going to write a post request, and I'm going to paste this message out, and then I'm going to take Office Desk out and just post this to the lights URL. And we see here that this is successful. So let's see what this looks like. Let's execute a GET request, and then let's grab that and see what it looks like and see if what we posted is actually added. And yes, there it is. We were successful at adding the Office Desk light. And then just for good measure, let's take a look here and see what happens when we query our get method about Office Desk. And there we have it. This is exactly what we'd expect from this method. With add functionality in place, it's time to add the counterpart of delete. So I'm going to define a delete method, and it's going to take a light ID as a parameter. And that's going to map to our existing URL structure. And what I'm going to do in order to make this happen is I'm going to load the data from our internal static data store in memory. And I'm going to basically go through and find from our internal data store the light ID or the light corresponding to the light ID being passed in. And basically I'm just going to store the rest of the lights minus this one. So using a little of this nice terse Python syntax here, I'm going to define an iteration through all the lights with the exception of the one being passed in, and I'm going to call that updated lights because that's going to be our updated list minus the one that we want to be deleted. Once I've done that, I'm going to save the lights collection that we're going to have in memory as this updated lights, and then I'm going to persist it back to this static variable. And once that's in place, this is going to give us the ability to both add and then delete a light. And I'm going to show you here in a second in Fiddler what that's going to look like. We'll go through the process of restarting the web server and then adding a light and then removing it so you can see that this is in fact working. So with that in place, let's restart the web server. And then I'll grab Fiddler here and we'll take a look at what we're going to do here is post the light in question, and then we're going to get it in order to confirm that we did successfully post once again, which you had just seen earlier. So once again, we have this Office Desk light in the collection. What I'm going to do now is go ahead and delete it. And we get a 200, which is good. And then I want to confirm that, in fact, the Office Desk light is now gone. We should have an empty collection. So I'll do another get on the lights collection. And I'll take a look at the results and see that we no longer have any lights. So delete is now working. So now the service is working correctly with all of the verbs that we want to define. There is a little bit of extra housekeeping here. First and most obviously, I'm going to get rid of this hello class and its corresponding route because there's just no use for it anymore. And then I'm going to do another thing, which is I'm going to define a method that is a consistent abstraction for retrieving the lights JSON from the store, and that's going to take no parameter. And the other thing that I'm going to do once that's complete is I'm going to define a similar abstraction for writing the lights to the store that takes the Python JSON in memory as an argument and saves. And the reason I'm going to do this is because eventually we're going to want to do something other than just having a static variable in memory that stores the appropriate JSON. So when we're ready for that refactoring or any other similar refactoring about where these lights are going to be stored, it's going to be easy to just come to one place and do that instead of kind of doing it ad hoc everywhere. And this is not just related to REST or to what's going on with the home automation light service or Python or anything. This is just a good design principle in general to have everything defined consistently in one place. So what I'm doing is going through here, and in all the places that I'm referencing this variable, either to read from it or to write to it, I'm replacing it with the appropriate abstraction. So what I'm going to do is I'm going to say that instead of reading from this variable, I want to call this method that goes and gets the lights from the store. And then I want to do similar things across the board. Here's where I'm writing, so I'm going to use the method. And I'm going to keep going down and doing that all the way through this file because that's going to make life a lot easier later for us when it comes time to actually make the change. And what's going to happen later on is that we're going to want to persist this and store it between sessions of the web service actually running. It shouldn't be necessary if you reboot the machine, for instance, to then have to re-add all of your lights. That wouldn't make for a very good service. So we need to be able to persist this to disk. And the first step in doing so is to get rid of all these inconsistent abstractions in places that we're doing all the right and just put it all in one place. And as you can see in the next clip, that's the point at which we're going to be adding the functionality for storing it to disk. So I am just about done here adding these methods in, and then we'll be done with this service in general on the whole, except to get it ready for deployment to production under Apache. So now we have a fully designed service, albeit one that's storing things in memory, and we're ready to move on.